everyone. Good day. Today I'm going to give you some study case of virtual works. Okay. Let's just get into it. Last time I already gave you the material about Truss structure. I used that structure to give you an example in this virtual works. I also already told you about what is virtual works and how does it works. In here, if you remember, the structure has 5 joints. It stands from beams and also a support. It concurrent at one point, we call it joint. There is 5 joint A, B, C, D, and E. On A, there is a support pin. On B, there is a roller support. And on E, that has an external forces. There is symbolized with weight, with this W, we call it W. And if you see the second picture, the external force work on that structure, and it makes the rigid structure change, or we call it there is a displacement over the joint C and D, and also there is a movement of the degrees of the rotation theta on C, also on D. So you see on here that the external forces affect on the rigid body of the truss structure. And how we define or how we compute this kind of structure or this kind of situation, first we have to define that there is two kinds. Okay, in here we have to define that in here okay, because after we pull by way in here, there is a movement or displacement on C to D. We call it F, C, D. Also in here, in D to left, for C to right, D to left. Also we call it F, C, D. There is a move. There is a structure changes on here. If you realize in here the degrees also have a displacement, and because of this situation we call it rotation of theta. In here also rotation of theta, right? Focus on the displacement, something that has changed from the last structure before external forces affect the body. Now we got the change of the rotation on both sides to and we try to figure out how to maintain the compatibility on E, because it's being pulled in joint E, which is by W or by W. In here we know that all angles in here are all angles in here are 60 degrees. And then on the rotation, okay, in here, because there is a rotation, rotation on C. There is a rotation on C. We could write it A sin theta. You already learned how to use sin and cos in this kind of situation. I mean, in every mechanical engineering situation. I don't have to explain more about that. And then it's times to its rotation theta. Also, it works for D. There is an A sin theta of rotation of the theta. And then don't forget that there is also a movement on E, which is we talk about A and the rotation of the theta. Because we have these 3 components already, how to calculate using a math computation. In here we know that the formula for virtual works is the virtual works on I mean, let's say, okay, the formula is d carry du for f times d r. Okay, there is a change in the structure. We talk about this formula and the definition from what we already know. In our situation, we call it the rotation of U. It's summarized from these three kind of things that we already defined. So it's pretty simple because we already got the FDC. I mean FCD. Okay, FCD times rotation on C plus FCD times the rotation on D, also W, the rotation on E, right, equal to 0. And this you could learn from your math teacher or on your math courses how to doing this all of the notation. But in here there's two FCD, right? And also in here the rotation of C and the rotation of D that we already know, it's a sin theta rotation theta. So in here a sin theta plus the rotation theta, we could write it later in here, W and rotation on E. So in here we call it a W and E and A. Where is the rotation theta? Because the W, the rotation on C, D, and E has the rotation theta. So in here, the rotation theta equal to 0. Remember that everything has to equal to 0 because sigma F equal to 0, sigma M equal to 0. And because of this situation, you could count it down how to solve this. But the result of this situation would be FCD equal to min W A sin theta. This is the answer of this situation. And don't forget, you have to learn by your own how to change this notation into this simple notation. Use your math skills for solving that situation. Okay, thank you. See you on the other case study.